Now I'm going to explain about mixture distribution, especially mixture of Gaussian, MOG, and it explains whether there is a distribution. It can be represented of the summation or combination of several Gaussians. For example, in this 1D case, if data is distributed in this manner, and we can't say any single Gaussian distribution can represent this, but it is not suitable. So we can assume there is 2 or 3 or 4 or more than like 5 or 6 Gaussians are combined here. Here I can say there can be one Gaussian distribution like this, and also here can be also one more distribution. So we will find out how many Gaussian distribution is in here. So let me briefly explain about the probabilistic background. If there is probability is x given theta, here theta is the parameter, and it can be, as I explained, can be represented of summation of each Gaussian distribution, and it will be distribution. And here we will assume this distribution is Gaussian, and there is a weight, so each data point has different impact on different distribution. So as I said, we will assume this distribution as Gaussian, so we can write it down like this. X given parameter is equal to 1 over 2 pi d over 2 multiply derivative of variance, and I'm sure you guys are all familiar with this Gaussian distribution or normal distribution equation. Yes, it is the equation, and here parameter will be pi, which is weight, and mu, which is mean, and standard deviation, it will be squared, and then it will be variance. And if there is m distribution, then there will be m variables, and in total 3 m's. So here that's why mixture m. Yeah. So now we want to maximize likelihood. That means we want to minimize error, which can be also explained minus log likelihood. Yeah, it is used a lot in machine learning theory or many kinds of things, and it can be represented as sum of probabilities here, and this equation can be further explained like this: minus sigma log sum of each distribution like this. So here I will briefly explain the intuition about this one, and this is distribution, Gaussian distribution, and it has its own case, mean, and covariance, variance parameters, and it has its own weight. Therefore, each distribution will be multiplied by weights, and they sum together. And finally, this equation will be just a probability, and then every single data point and any data point here, so we'll sum up all the errors on datas, then we will calculate our likelihood or error. So because log likelihood has a minimum point, so if we want to calculate error and partial derivative of error with regard to mean value, and if we found any mean value which makes it 0, then it will be the optima. So I can say, because we want to derivate this equation firstly, there is a reason I use it first, just please follow me here. And it can be explained like this: p x given theta and p x given theta parameter. And here, if there's someone who don't know this theory, if you want to derivate y, which is log function, then y prime y x will be 1 over x. So we have this equation, okay? And it can be further explained like this. Sorry. Here, covariance and x minus mu j. This is coefficient after the derivation xn given theta j, and it will be large K, small k, p, xn given theta k, and obviously this probability, the total probability, is represented like this, because this total probability can be explained by multiplication of this each probability. And here, for those who don't know about the derivative of normal distribution, it can be explained like this. So it is equal to n minus mu j and multiply the original function, because this is the exponential function, so it does not change its own shape, but only the coefficient will come out, because as I explained and we learned here, this is the equation of normal distribution, and because here mu j is actually squared term, so here 2 will going outside and will be multiplied 2, and here is minus, so minus 1, and this is also coefficient, so multiply inverse of variance, so cancelled out. So this one will be just plus, so here it is, and because this is second order, first order will come out here. So we can calculate it like this. So if we solve further, then I will expand this probability equation by following this term. Okay, so here's minus, because this is the constant matrix, or just constant in case of one dimension, so it is going outside, and sigma n xn minus mu j, and here again quickly write this equation. Pi j so this pi j comes from this weight. This weight can be represented as weight here, and we will write this probability equation here because we assumed it is Gaussian distribution. Alright, so or as we discussed, we are going to find 0. Then because it doesn't give any help for us, and even this one already cannot, sorry, it will be acts as a really important factor, so we will say it as responsibility of distribution J on data X n. So clearly I can rewrite this equation as because mu, which is mean of distribution, is always the same, so it can go out of the some sigma. So here finally I can say, alright, I get the mean value which minimize the error or maximize the likelihood is this value. But here's the problem, because mu, mean value, has a relationship with gamma here, but here gamma also has a relationship with mean. That means we don't have analytical solution in this calculation, therefore we will approach by iterative equations. Alright, now we can go to and jump into our main topic, EM clustering. Because as we discussed, we are not sure how which distribution will work for this data. So this method is kind of clustering with soft assigning or assignments. And I will give you the derivation of this equation, then you will realize why it is softly assigned distribution. So as we discussed, probability can be divided with each distributions. So this is weight, and this represents the probability of distribution, so Gaussian distribution for us. So let's say I want to know the probability in the data point X, like if there is combined data like this, and I'd like to know in these points how many probability of the distribution 1 has. So it represents that. So it can be expanded like this. This is probability theory. So for those who don't know this theory, like if A given B, the conditional probability is same with P probability A and B over PB. So I think you remember this equation, then you can understand these lines. And here I will solve this probability like this: P x given j is equal to 1 comma theta multiplied with when j is 1. So this is Bayes' theorem, and I can shorten this equation like this. Because simply these two and theta 1 is same, right? And here the probability of this one can be also represented as, because this is the distribution of general case, so it is sum of each probability or distribution and multiplied with or weighted by this probability weight. So this is same with x given theta 1 multiplied by j is equal to 1 sigma 2 j 1 probability of x given j theta pj. It is same with j and xn. I think you are familiar with this equation because we have solved this value here. This responsibility is calculated from this one, and it has exactly same structure. Here's the weights and distribution and sum of every distribution. Okay, yeah, it is same here. So now we finally calculate how we can get the responsibility by theoretical probability theory. Now, really, finally, I'm moving into the algorithm of EM. Firstly, there is expectation. So we will calculate responsibility as we did. Okay, I'm writing this equation so many times. So I think you guys will be also familiar with this equation. Then you guys already have done more than half. I can say that. Pi k, weight and distribution. So again, it's really important to understand the concept and intuition of this responsibility. There is many or several distribution, and J's distribution will have a responsibility on data xn. So each data has different will be affected to several and different distribution, and this responsibility can be calculated from each distribution, which is weighted by some ratio or probability. So once you calculate this expectation, we are moving on maximization step. Firstly, you will calculate n hats, and it can be calculated really simply, just sum of responsibility. So, okay, let me fold this paper. So, let's say there is several or many data, and there is one distribution, like let's say this is 1, and this is 2, or I will probably like 3, and each data point will have its own gamma 1 x1, and it will also have gamma 1 x2. How can we calculate this equation? All right, from here. Okay, so this one also has responsibility on distribution 1 on data 1, 2, 3, 4, 5, 6, 8, 6, 7. All right, 7. Sorry, 7. And obviously, this point also has a responsibility on distribution 3, x1. So you just sum this responsibility here. And probably you have a doubt about this value, but once you see this one, new weight on this jth distribution can be calculated by like this. So this n is kind of imaginary number, not exactly imaginary number, but some virtual number which represents for this each distribution. All right, so you can calculate this weight. So this weight is used here later, and we will update our mean again, and it will be calculated by this. It is kind of intuitive to understand, because here I said it has a relationship with this equation, right? So that's why we are using n here, and it is working as kind of weight toward data. So we can update our mean value of jth distribution. For example, this distribution, this mean, or this mean. Okay, and if you understand this step, next thing will be easy. But before we are going on the variance, we already solved like this. We already calculated this is the best mean value, which minimize the error or maximize the likelihood. That's why we are using this equation for new mean value. But it is really intuitive to understand. Lastly, this is new variance, and equation is again really intuitive. Here xn minus mu j nu n minus mu j nu transpose, and you can see this value is used here and again here. So in summary, firstly, we are not sure how distribution will be distributed. So there will be some initialization step, and then we'll calculate responsibility first here, and this responsibility is used when we calculate new n and weights and new. That means we update our mean and update our variance, and we repeat this on and on and on. Then we will find best distribution, best combination of distribution, which we can explain any points. So theoretically, if the k increase, if there is many this Gaussian distribution, then we can represent any kinds of things theoretically. Okay, I hope my explanation helped you guys. Thanks. Bye.